This chart tracks the survival of concrete repairs over a 10-year period, according to data from 215 cases surveyed by the European Repair Industry Network. Within 5 years, one-third of those repairs fail. By year 10, the success rate drops to just 30%. In the swimming pool industry, the timeline is often shorter. When a concrete pool shell is patched using standard methods, debonding cracks routinely return within 12 to 24 months. When industry engineers analyzed these recurring failures, they discovered that in every case, the repair products themselves performed as intended. The resins and dyed mixes are rarely the problem. The failure lies in the methodology. A patch separating from a pool wall is a predictable mechanical breakdown. It happens when the repair ignores the structural physics that governed the original shell. The standard industry response to a structural crack or a skimmer replacement involves a jackhammer, a few holes drilled for rebar, and several bags of concrete mixed in a wheelbarrow and packed into the cavity by hand. Engineers treat vanishing-edge walls and skimmer cutouts as critical load zones. These sections hold back thousands of pounds of water and are designed to function as part of a continuous engineered structure. A complete system of written standards, including ACI 562 and the California Building Code, exists to govern these repairs. These documents provide a specific sequence of requirements that the manual wheelbarrow mix method cannot meet. We are going to trace the engineering evidence to see exactly where the wheelbarrow repair breaks the rules of structural concrete. Every structural repair must satisfy 5 specific technical requirements. Leaving even one unaddressed leads directly to bond failure. Under ACI 562, a repair begins with a professional assessment of the root cause. This is followed by substrate preparation, which is where the mechanical failure of the patch usually begins. Impact demolition creates a fractured layer known as bruising. This microscopic network of microcracks extends 3/8 of an inch into seemingly sound concrete. ACI 546R warns placing new concrete over this bruised layer causes immediate bond failure. The new material tears away the fractured surface. Correcting this requires saw-cutting the perimeter to create a square edge and undercutting the rebar. This allows the new material to wrap fully around the steel, creating a mechanical lock. Tapping the concrete is not a valid way to check for bruising. The code requires an ASTM C1583 pull-off test to verify a bond strength of at least 100 psi. Without a mathematically verified substrate, the new wall is being built on a microscopic foundation of shattered glass. The third requirement is the engineering of the interface and the reinforcing steel. It is common practice to drill a hole and epoxy a short rebar dowel into a crack based entirely on worker intuition. ACI 318 requires the new steel's embedment depth and load transfer capacity be calculated, ensuring it can move the water's immense force into the structure. Epoxy manufacturers condition their published strength values on specific hole dimensions and a series of mandatory wire brush and compressed air cleaning cycles. A dowel epoxied into an uncleaned hole without a verified design has no code-recognized structural capacity. The steel is effectively useless if the chemical anchor hasn't been engineered to transfer the immense dynamic load of the pool. Next is the placement of the material. In the standards, concrete is the material, but shotcrete is the placing process. For swimming pools, the concrete must achieve a minimum strength of 4,000 psi and a water-cement ratio of 0.45 or lower. This low ratio is what makes the structure watertight. Bagged concrete mixes often instruct the user to add water until a workable consistency is achieved. Following these instructions typically destroys the water-cement ratio, resulting in a porous, weak patch. Because of these consolidation issues, ACI 309R limits manual hand packing to small, non-structural placements. Shotcrete works through high-velocity impact. The speed of the material achieves maximum compaction and forces a dense bond with the substrate that hand packing cannot replicate. Hand packing dyed concrete into a structural cavity violates the physics of material consolidation required for a waterproof structure. The final requirement is independent inspection and proof. When the pool was first built, the law required a continuous special inspector to watch the structural placement. IBC Table 1705.3 demands continuous special inspection for shotcrete placement and for the installation of horizontal adhesive anchors. Major jurisdictions like Los Angeles require separate dedicated deputy inspectors specifically for gunite and for drilled-in anchors to ensure these standards are met. The California Building Code mandates permits for the construction, alteration, and repair of a structure. Rebuilding a structural zone without a permit or a deputy inspector leaves the owner with an undocumented liability that lacks any legal or engineering evidence of its strength. Hand tools are not inherently problematic. They have a legitimate written domain in concrete maintenance. ACI RAP 6 defines that domain as shallow, surface-level spalls that are purely cosmetic in nature. For deeper structural work where a full shotcrete crew isn't viable, the codes offer alternatives like Foreman Cump or epoxy injection. The requirement for diagnosis, engineering, and inspection defines the threshold for structural intervention. A chipped-out skimmer or a through-wall crack sits unequivocally on the structural side of that threshold. Before starting a structural pool repair, there are 5 questions that force professional compliance. 1. Who diagnosed the cause of the crack in writing? 2. Where is the engineer's repair design? 3. What is the qualified placement method? 4. Where is the permit and the inspector? And 5. How will the bond strength be proven? A pool shell is built under the supervision of an engineer, a permit, and a full-time inspector. The laws of physics and the building code require that it be repaired with that same rigor.